to discuss biobanking and the exposome. And this is going to be a presentation by our host, Kurt Zatloukal, who is the head of the Diagnostic and Research Center for Molecular Biomedicine here in Medical University of Graz, and the director of BBMRI Austria. So, Kurt, the floor is yours.
Thank you so much. It's my real pleasure to welcome you here. And actually, there are many good colleagues and friends who jointly participated in many previous projects related to biobanking. And I think the exosome brings a very important additional dimension to this whole field. And therefore, what I would like to highlight in my presentation, where this added value or these synergies are focused on. To start, I show you a slide you may find on our website. Actually, this is the scientific vision of the Center for Molecular Biomedicine here at our university. This integrates 4 institutes: pathology, human genetics, hygiene, microbiology, and environmental medicine and forensic medicine. So we already can cover many of those aspects. And why is this so important? Because what we see is one of our big challenges we are facing is to get a better understanding how the environment with all its factors impacts individual health or disease. And of course, we have so much focused on the genome in the past, but we have missed some very important elements in the equation. This is the environment. And there is another element which is in between, that's the microbiome. So if we want to have an understanding, we have to look on all these elements. And if we think in the past, biobanking has developed a lot of experience and solutions to address, let's say, alterations on the genome level, the proteome, the metabolome. We have learned how to collect the samples properly, how to analyze them. But what we have not really developed, how to capture information on the individual exposure. And here the knowledge is missing in the biobanking community, and therefore I think it's such a great opportunity having now dedicated activities that focus on the exposome. Now on the biobanking side, we have here this European infrastructure for biobanking and biomolecular resources, and several of the participants were involved in designing and developing and implementing this infrastructure. It's currently run by 18 member states, and what you see here, this is not institutions, it's not individual, it's member state countries. And ERIC is a very official kind of infrastructure which is owned, financed and operated by the member states. We also have observer members for those who could not adopt this ERIC status at the moment. So this is some fade-in opportunity, which also allows countries outside of Europe to participate and to collaborate with. Now, a member state participates in such an infrastructure through a national node. This is a typical model for the so-called distributed infrastructures, meaning where you have the operational activities at many places. And this national node is also coordinated here at Graz at our university, and it integrates essentially all the medical universities into this infrastructure program, but in addition, the University for Veterinary Medicine, the University of Vienna taking care of the social science dimension, and the Alpe University taking care on the data management element. What is interesting here in Graz, and therefore I'm particularly glad to welcome you here also today, is that we have a unique situation that literally in one building, under one roof, we have all 3 elements you have in a biobanking society. We have here the European headquarters. It's the building around the corner, you may see it. We have on the same floor the coordination unit for the national node, and 2 floors below the local biobank of the medical university. So I think we have here a very nice integration of these elements at our university, and hopefully we'll have the opportunity to visit also our local biobank. Now, what does BBMRI do, and how do we see our role in the scientific community? It's first of all enabling high-quality collaborative research for academia and industry. What is very important? the role of biobanks was misinterpreted by the community. Many people expected from a biobank, it's like an Amazon store where you have a list, you select what you want, you pay for it, and you get it on the next day. That's not how biobanking works. Yeah? And we really have to raise awareness what the actual contribution to the scientific community is. And at the end, it's about enabling, supporting high-level research. And we don't really distinguish between academia and industry. And in this case, of course, the samples and the data are a key element of this research. And we have to provide access to quality controlled biosamples. And the quality controlled is a very important element, which I will highlight in a slide later on, in an ethically and legally compliant manner. And this point becomes increasingly, let's say, a roadblock or whatever you call it, because we have a very complex ethical and legal landscape, even within Europe. And for individual scientists, it's almost impossible to manage a project that runs in different countries. So this knowledge has to be provided and made available to the scientific community. And this is a very important role of this research infrastructure, to do this work and offer this knowledge to the scientific community so the wheel does not have to be reinvented every time. And then providing research services and education training. But there is additional impact. And this is also the structuring effect on the national scientific community. And actually what we learned, wherever the national node was implemented in a country, this allowed also the government to structure the national scientific community. Without such a process would not have happened. Because scientists grew up to survive in a competitive environment. So they actually were trained and selected to compete with others, not to collaborate. And participating in such an infrastructure brings in a complete new mindset and culture, creating added value through collaboration, increasing competitiveness through collaboration, not fighting against each other. And if you want to collaborate, you have to agree on common procedures and standards. So implementing this common procedure and standard is very important. And also what we observed, and I think there are very exciting examples, for instance, in Finland, the FinGen project. We also see it here at our side. When you have done your homework, structuring the environment, you get a preferred party for also private investments. Because all the money that is invested in R&D simply delivers more results than if you invest it in a non-structured environment. So I think there is a good return if you do this exercise. Now, some more details. What can this infrastructure contribute to the HEAP project and the exposome community in general is, first of all the work that was done in the previous years, how to standardize the collection of samples, how we preserve biosamples properly so that they are appropriate for molecular analysis, experiences in processing identifiable data for research. This is not an IT issue alone, it's also this ELSI aspect. And then also we can make this knowledge available, we can share the technologies. It's very important that this is also what we deliver to the community. It's not just providing access to samples and data, also providing access to knowledge, to experience, and technologies to be developed. Just a few examples why this is important. Maybe you have seen these slides in this many biobank presentation conferences, but for those who have not seen that, this is one of the few studies that try to quantify the damage due to lack of reproducibility of scientific results. And this study was done in the United States, in the pharma industry, looking at preclinical research. And what they found that about half of the investment made in preclinical research is lost because data cannot be reproduced. And that's huge money. Yeah? The annual spending is about 56 billion a year. So you can say 28 billion a year are lost because data cannot be reproduced. And then they further look, and what they found, okay, I have to look here. Oops, no, doesn't work. Anyway, you see it in the upper right, more than 1/3 of this loss was attributed to the biological reagent and reference materials. So it was the quality of the material that was analyzed. So if we can improve quality and we can standard quality, it has enormous implications on data reproducibility and, of course, all its economic implication. And this was a major driver also of how we have to find a common quality basis. And actually what we decided, not developing our own standard, which we would consider as another level or contribution to a fragmentation. Yeah? So we said, let's find a process that is accepted already in most countries around the world. So we try to use ISO standards to create this common basis. And actually there's a series of standards already developed that emerged out of these programs and initiatives relating to different types of biological materials, tissue, blood, body fluids, but also the microbiome, saliva, extracellular vesicles, and so on, and related to the various annelids that are of interest, and including also the metabolome and metabolites, which are in the focus also of exposome research. And these are now mirrored in a series of ISO standards that should provide this common basis. Now, on the data element, when we talk about biobanking, it's not just a sample, it's also the information. A sample without associated information is mostly useless for most kind of research. And there's a very important element, and here's a quotation from a report from the UN Secretary General, a high-level expert group. They say gaps in data on which algorithms are trained can likewise automate existing patterns of discrimination, as machine learning systems are only as good as the data that is fed to them. What does it mean? If the data is not of appropriate quality, the result will be also garbage. So we have this garbage in, garbage out problem on the sample side, but also on the data side. And the data quality is not just only, let's say, related to individual data item. It also refers to the, let's say, how well the data represent actually a population. Having data only from a very small subgroup of people, even at a high quality, is not appropriate informing us on general health issues. So we need means that allows us to make the data accessible from a very large diversity of people available for research. And here we not only talk on Europe or US, we really have to see it in a global context. And therefore it's important, we have to think about how we create an environment where this data can be hosted and made available for research. And there are a couple of elements to build such a trusted environment. You need a legal basis. In Europe it's GDPR, there's other legal bases in other parts of the world. But really look, it's really in the center. It's the engagement with the people. And this is so often ignored. It's very often seen from the legal side, the technical side, but if you want to build trust, you have to talk to the people. And you have to talk to the people from the very beginning, not when you have a solution which you then want to sell to the people. That does not trade trust. Then you need governance, but also there's technology that helps us protecting the data, but also protecting the people in privacy. And then a very important element, particularly in the global context, is the fair benefit sharing model. I cannot go into detail because of lack of time, but please keep it in mind. Also, it's very important when we build such a trusted environment, we have to think about what is the appropriate access procedure. In the past, typically access was provided once there was a request. This request was evaluated by an access committee. Once the LC compliance was confirmed, the data were released, were sent to a user. The problem is sending data away, you essentially lose control. And you cannot, for instance, control whether the data will be re-identified because you combine different data sets and so on. So therefore we are thinking, can we change the way to provide access to data? Very simple to sample is, what should we do? We put the data in an analysis environment and allow external users to analyze the data and to take the result. And I think this might be also interesting for the exposome field. Also very important, you all know the news. Almost daily, you get information that some organizations have been hacked, including universities and whole national health systems. So how can we, let's say, create trust that the data are properly protected in such an environment? So therefore, we're also investing in exploring new ways to ensure cybersecurity. And just one example, for instance, we are now testing new encryption technology that essentially cannot be hacked, and even quantum computers are not able to retrieve the information behind the data. The way it works, that you not only encrypt data, but you also generate different fragments you can store on different cloud entities. And we're using this model, for instance, to create here such a secure data environment for health data, which we now want to test between the different national nodes of the biobanking infrastructure and also with Elixir, maybe using one of the running cancer mission programs as a template. Yeah, I'm coming to the end. And a very important element also is when you participate in such an infrastructure process, that this is a door opener to participate in many national and particularly also European funded programs. Your success rate is much higher if you do it in the context of a research infrastructure than you do it as an individual scientific group. And of course, it's always only possible if you have a great team behind you. And really, I would like to acknowledge in this context, I cannot go through all the names here. Some are sitting here, Cornelia Stumpner, but particularly Heimo Müller and his team, who allowed particularly developing all these elements in the starter space. With this, I would like to stop and thank you so much for your attention and particularly look forward for collaboration. Thank you.